Example 5. Let's evaluate the integral of dx over the square root of x squared minus a squared, and we'll keep a being positive because a can be either positive or negative. Later on we'll see the effect of this. So look at the table, and what substitution we're going to employ here? The secant. So a secant theta, and of course dx need to be substituted, replaced as well. So the derivative of the secant is the secant tangent. Okay, 5 minutes warning. So let's see what happened now. Now, one thing that we need to remember also, let's just recall the boundaries where theta is a value greater than or equal to 0 but less than pi over 2, or this is for the positive values, for the negative value greater than or equal to pi but less than 3 pi over 2. Okay, just to recall that we need to have that in place. And now let's look at the denominator and see what happened. X squared minus a squared will give you the square root of a squared secant squared theta minus a squared. Of course, factor out the a squared and you end up having a square root of secant squared theta minus 1. Now, do you remember what's there? What is how we substitute secant squared minus 1? With the tangent. Right. So we end up having a times tangent theta. Okay, just recall here quickly that secant squared of theta equals 1 plus tangent squared, and therefore secant squared theta minus 1 equals the tangent squared. So that's what we did. Okay. So now we are ready to close the deal here. The integral, can you close the door please? Somebody who's sitting next to the door. We're going to substitute dx, and I equal, instead of dx over the square root, okay, we have the integral, the numerator dx is, we have a secant tangent d theta, and the denominator will be simply a tangent theta. So let's see, we have all kind of cancellation here. A cancel a, right? Tangent cancel tangent, and we end up having the integral of the secant. Now, this is what we did on Tuesday. Do you remember what is the integral of the secant? It's a natural log, and in calculus, it will be the absolute value. Natural log, you immediately follow. It's the secant, now plus the tangent, plus c. Now the problem is, I have it in theta. I need to find a way to write it in terms of x. Okay. So going back to the substitution and say, okay, x equal a secant theta. So we get the secant right away. The secant will be replaced by x over a. But also I need to replace the tangent. Okay? If the secant equals x over a, then the cosine equals a over x. And I'll use this in building our little right triangle. Could have built also the secant. Okay? So the cosine adjacent over hypotenuse, right? A over x, and therefore the opposite will be the the square root of the square of the difference. So it will be the hypotenuse squared minus the adjacent squared, or the square root of x squared minus a squared. Remember, I told you, when you build a triangle, the missing side always going to be the radical that you started with. Now we are in search of the tangent theta, therefore will be the opposite over adjacent. So we are looking at the square root of x squared minus a squared over a squared. And now we're going to say that the integral I will be the natural log of absolute value. Instead of the secant, we have x over a, and instead of the tangent, we'll have the square root of x squared minus a squared over a squared, and we close the deal like so. So this was example 5. I have 2 more that I want to show you. This will wait till tomorrow. And there was a good question. Don't go away. There is a mistake here. I did not. That a squared is wrong. The tangent is the square root of x squared minus a squared over a. Thank you, Courtney. You were absolutely correct. So make a change, and with that, time to go. It's actually precisely the time to close the class.